My name is Anthony Lozano, and this is my presentation on the Kalman Car Counter. It's an implementation of a computer vision traffic data collector. So what does that mean? That means I can process videos and find the cars in them and count them as they go by and produce traffic data. So why is this important? Well, traffic data is important to a lot of people. Civil engineers need it so that they can plan when to build new lanes on a roadway or change the timing on traffic lights. Policymakers need it to decide when to build, new bridges and when to add bus routes and mass transportation and new roads. Business owners might be interested in traffic data simply to find out if their business is going to have a lot of traffic near it so that they can get more money, more business. You can even use traffic data to do some environmental emissions estimation and other estimations. So what's the problem? Well, it's hard to collect good traffic data. The existing methods like these software tools, like the one I'm trying to design, are pretty expensive. Hardware tools like loop sensors in the ground or studs that can count cars that go on top of them, they require a road shutdown to install, they require hardware, and you have to damage the road to put them in, and there's some maintenance involved there. There's other kinds of sensors, pneumatic loop sensors you might have seen. They roll these pneumatic loops out across the road and it tracks the number of cars that go by. Those have some problems too. Foremost, you have to shut down the road. So shutting down the road in an urban area can cause a lot of disruption, especially at the time of day that you want to collect traffic data. Some other methods, you could have humans manually count the cars in the video or just stand at the corner, but a lot of humans don't want to do that. So can we track the cars in the video well enough to collect traffic data? Yes, we can. So the way we're going to try and do this is by building a computer vision analysis of the images in the video to track cars. We're going to take tracking of car data and try to feed it into a Kalman filter to predict where the cars should be going. If those predictions turn out to be accurate, we can say that we found the car, and we can count the car as it rolls off the screen. If we can make such a system like this, then it can save a lot of people a lot of money, and they don't have to buy an expensive system. And then anybody with a camera and a decent vantage point could collect and contribute to traffic data. So say a business owner doesn't have access to a county traffic database for traffic data. He could just go to the overpass and get the data himself. So how are we going to do this? There are a few steps we have to take. The first thing we have to do is remove the background from the video. What that means is we need to get only the things that are moving in the video, only the cars. It'll include things like birds, and the shaking of the camera will produce some other features. But background subtraction will help us find the features that we care about. So then we have to actually find the features that we want to track. And the way we're going to do that is with a Shi-Tomasi corner detector. Once we found those, we're going to feed them into an optical flow, which is a Lucas-Canard optical flow calculator. And then with those set of tracked features in hand, we're going to cluster the tracked features to produce a single data point. That single data point is going to be fed into the Kalman filters. We're going to assign a Kalman filter to each one of those clusters, and we're going to track those clusters as they move through different frames. And if we can track it when it runs off the screen, we call that vehicle tracked, and we can count it as leaving the scene in a particular direction. This first video is just a video of the overpass that I took. It's a hot sunny day in Phoenix, Arizona. You can see the cars going by. The camera shakes a little bit. This is because I'm just holding my cell phone camera. No special tripod or mounting or image stabilization is going on here. Just me at the overpass holding my camera as steady as I can. The overpass itself shakes, and these shakes might not seem important, but when it comes to background subtraction, we're actually going to see that they do have an impact on what we're doing. But it's not too bad. It's not something that we can't overcome. So let's take a look at what the background subtracted image looks like. So this is the background taken out of the image, and this is where we're actually going to be performing most of our corner finding and feature finding on. You can see that, yes, because the camera is moving, the noise from lanes and bushes and tree lights and barrels comes in. But the important thing here is that the cars show up really well, and they have a lot of corners. That's what we're looking for, so that we can find the features that we want to track, and we can feed those features into the Kalman filter. So now I'm going to show you what it looks like when we find the features and we cluster them. Here we have our clustering algorithm running. It's clustering these data points here, as you can see on the motorcycle. Those two clusters were the same, but then as the cars diverged, it was able to determine that there was two different clusters there. So those clusters would form a new Kalman filter, and that new Kalman filter would track the new car. So finally, I'm going to show you the Kalman filter in action. So these little blue circles are the common filters tracking. You can see track that motorcycle and that car pretty well. Some of them spring into existence and quickly don't find where they're supposed to go, and then they fade out of existence. But mostly you can see that a lot of cars do get successfully tracked as they're going up and down the highway here. So that's my presentation and my implementation of a Kalman Car Counter. If you have any questions, feel free to post them on the video comments or email me, and I'll try to answer them as best I can. Thanks for great class, and I will see you guys next time.